In this video, we're going to be discussing annuities. So up to this point, we've talked about simple interest and compound interest, and both of those we use in relation to a single investment. So you're putting money into an account or an investment once, you let it sit for a while, how much interest do you have at the end? So an annuity is a slightly different type of investment. Instead of putting money in just once, you're putting money in on a regular basis. So it's the same amount of money being paid every month or every week or every day. And we use it for things like making regular contributions to an RRSP, which is a retirement savings plan, or an RESP, which is an educational savings plan, or if you're buying a house and you're making mortgage payments, or you buy a car and you're making car payments. Anything that involves a regular payment of the same amount of money on a regular basis is for an annuity. So we're going to do a couple of examples here, but we're going to start out by modeling what an annuity looks like when you're actually calculating one, and we're going to see if we can come up with a formula. So it says Marty and Ethel want to save money for their son's university education. They decide to invest $100 each year for the next 5 years in an annuity that earns 4% compounded annually. How much money will they have at the end of 5 years? So first of all, the reason I can tell that it's an annuity and not just regular compound interest is that it does say that it's $100 not once, but every year. That's the clue that tells me that it's an annuity. So if it says each year or each month or each day, that's always a good clue that it's an annuity. So here we know they're putting $100 into an account every year, right, for 5 years, and they're going to be earning 4% interest. So I have a little table to model what's happening during those 5 years. So in the first year, they walk into the bank, they open their account, they put in $100, so they have $100. In year 2, when year 2 rolls around, they earn interest on what's currently in their account. So they earn 4% of $100. So to calculate that, I'm going to take 100 and multiply it by 4%. So I can either do 4 divided by 100, or I can do 0.04. So 100 times 4 divided by 100 is 4, which means they earn $4 in interest. Now to that, they're adding another $100 out of their pocket. So at the end of the second year, they have the $100 that they had before. They earned $4 in interest for the year, and they put in another $100 because they're going to put $100 in every year. So 100 plus 4 plus 100 means they currently have $204 sitting in the account. Year 3 rolls around and they earn 4% of what's sitting in their account. So if they have $204 there, they earn 4% of $204. So I can multiply by 4 and divide by 100, or I can just multiply by 0.04. I need my calculator for that. So 204 times 0.04 is $8.16. So they will earn $8.16 in interest in year 3. Okay, they add another $100 into the account. So they have that $204 that they had at the start. They add to it $816. Sorry, $8.16. And then they put in another $100 into the account. So $204 plus the interest of $8.16 plus that new deposit of $100 means they now have not that much money. All right, one more time. 204 plus $8.16 plus $100 means they now have $312.16. All right, so year 4 comes around and they earn 4% of that $312.16. So they get interest on whatever was in their account. So I'm going to find 4% of that. So 312.16 times 0.04 is $12.49. And then they put another $100 into their account. So they have the $312.16 from last year plus $12.49 in interest, plus that extra $100 that they threw in, which means they now have $312.16 plus the interest plus the new amount that they're depositing. So they now have a grand total of $424.65. All right, last year, okay, they get interest one last time. So they earn 4% of that $424.65. So 424.65 times 0.04, they get $16.99 in interest. To that, they're also going to add in their last deposit of $100. You'll notice they did 5, one every year, which means their grand total, they've got that $424.65 from the previous year. They're adding their interest of $16.99, and they put in that one last deposit of $100. Let's see, 424.65 plus 16.99 plus 100 gives me $541.64. So at the end of the 5 years, they're going to have $541.64. Now, how much of that is interest? They put in $100 5 times. So out of their own pocket, they put in a grand total of $500, which means that they got $41.64 in interest, because that would be the difference. Now, what I would like to do is I'd like to be able to find a formula that I could use to calculate this instead of having to do the table all the time. Because this isn't so bad if it's being done annually, but if this calculation was being done daily for 5 years, this table would go on forever. So we're going to try something, and you're going to have to bear with me here. We're going to take a look at trying to find a way to express this using a formula. So in the first year, they put in $100. In the second year, they put in a new $100, and the $100 that was there from the year before earned some interest. So there was $100 there plus 4% interest. Now, one way you can calculate what the two of them are together, if you do 100 plus 4, that's $104, which would be the same thing here as multiplying it by 1.04, because 100 times 1.04 is $104. In year 3, they put in $100. That $100 that had been sitting there that we put in last year now earns its own interest. So it earns 4% interest. So I multiply by 1.04. And this $100 that already earned interest once earns interest again. So we do 100 times 1.04 times 1.04 again. And since I'm doing it twice, I'm actually just going to say that's the same as 1.04 squared. In year 4, we put in another $100. Well, they put in $100. This red $100 earns interest. Oops. So I multiply by 1.04. This orange one here has already earned interest once, and it's going to earn interest again. So it will have earned interest twice. So we will have multiplied it by 1.04 twice. So I'm going to square that. And then this one here gets multiplied by 1.04 again. So instead of being squared, it's now going to be cubed because it's now happened 3 times. All right, we're almost at the end here. This last time they put in $100 one more time. The $100 they put in last year earns interest. The $100 that they put in the year before has now earned interest not once but twice. This $100 here has now earned interest 1, 2, 3 times. And that original $100 has earned interest 1, 2, 3, 4 times. Okay, so why did we do this? What we're trying to do is come up with a formula here to show how we can calculate this. And this is actually something that we saw in our previous unit. I have a list here. I have 100 plus 100 times 1.04 plus 100 times 1.04 squared plus 100 times 1.04 cubed plus 100 times 1.04 to the 4. This is actually a geometric series, right? It's a series because we are adding all of our terms together, and it's geometric because we're multiplying by 1.04 to get the next term. So what I'm going to try to do is see if I can use our geometric series formula to calculate how much money they would have had. We're going to see if it works. So the formula for a geometric series is Sn equals A times r to the power of n, take away 1, over r, take away 1. And I've got S, A, R, N. So looking at what we just figured out, A would be the first term, and our first term here was 100. So I'm going to put A as 100. R is what we're multiplying by every time, and what we're multiplying by every time here is 1.04. N is the number of terms, and if I count them up, we've got 1, 2, 3, 4, 5 of them. So that's 5. And then I'm just going to substitute the values in. So S, I don't know. I could say it's S5, or I'm just going to write S. A is 100. R is 1.04 to the power of n, which is 5. Take away 1 over 1.04. Take away 1. Now I'm just going to simplify this. So I have 100 times 1.04 to the power of 5, take away 1, over, that's going to be 0.04. And then if I use my calculator and I calculate that, 100 times bracket 1.04 to the power of 5, take away 1, close bracket, divided by 0.04 gives me $541.63. Now that's pretty close. Here we had $541.64, and here we have $541.63. And the reason it didn't come out perfectly is that we did some rounding up here, and that's why it didn't work out to be exact. Now, what I want to do is see if we can use this to come up with a formula. So I'm actually going to take a look at this step right here and see if we can figure out where some of those numbers came from. Now, the $100 that's there, that was our starting amount. That was how much they were putting in each time. So I'm going to call that the payment. That was their payment that they were putting in. Okay, the 5, I recognize that. That was the number of years. They were doing it for 5 years. And the 0.04 that shows up in 2 places, that's what our interest rate would look like if we made it a decimal dividing by 100. So this is going to be my interest rate. Okay, so in the next part of the video, we'll actually put this together into a formula.